Is there anything better than a PWM signal? And you just love it. That's just cool. So again, I'm still thinking in my head as I'm going through this, what if anything needs to be changed from the curriculum? So I just finished recording the video and I realized it was 40 minutes. So I'm going to interrupt this one here because I did one worksheet and then I did the next one. Well, I think it was worksheet 9, worksheet 10. Interrupt this one here. We'll end this video here and then I'll make the next worksheet into a separate video. And then hopefully you guys will see that I end up whacking out this big oscilloscope and having some fun with the other motor. So yeah, you don't want to miss that. Cool. So worksheet 10. Brushless DC motors are lighter in weight than the normal DC motors. Okay. Compare the two motors on the DC motor brushless motor board, both rated at 50 watts. However, the brushless motor needs a complicated 3-phase wiring power supply to generate separate power signals for the 3 stator coils. So that's this one here. So if we look at there, it's saying the inputs are brown, black, grey, plus some sort of control, I guess, or feedback or encoder circuit there, versus the DC motor, which versus the brushless, which just has a red, black, positive, negative. Cool. This thing's heavy, which is nice. Like that ain't going anywhere. All right, so where we're at. However, the brushless motor needs a complicated 3-phase. Blah, blah, blah. It is so efficient and powerful that this complexity is worth it. Okay. Photograph shows a brushless motor mounted on an axle. All right. So build the circuit shown above. So we essentially just have, let's get rid of our scopy boys now. Show you, like, what I love about electronics is the ease of use, like how easy it is for me to just pop this all out and just make an entirely new circuit. It's just cool. And when I first saw this, I felt like it was just for kids, but as I'm using it, like, it's very high quality, to be fair. So fair play to Matrix to have made a very good product here. This electronic stuff is cool. So what I have is I have my 12 volt input coming from that DC power supply there. So we're gonna stick that there, bob this all out, and then what we're doing, we got one connecting, one there. Look how nice that just pops in like that. And then we've got a switch of some sort. So I've got some trays of these. This is how they come. Oh, honestly, very, very high quality. I'm amazed at just how nice everything feels. So that's not the tray I'm after. Got a bag of bits there, and then we've got a different tray. I've got about 8 of these trays with me that I need to go through and test. So what am I looking for? I'm looking for a switch of some sorts, which oh, here you go. There's a switch. Look, I was looking straight past it. So we stick our switch in here. Honestly, this is one of the best products I've used in a long time. I mean, this feels great. So what's this? This is a, do I just lift it up? Because that's touching right now. That will make a solid, that'll make a connection. Am I supposed to break it? Okay, cool. Right, so that's an open switch now. So you can see there. I've opened that. Cool. What's next? So, oh, okay. Positive to where we're going. So positive's going to the motor, the negative going to there. And then I don't need to wire anything over here. I don't think. The DC, the brushless. Yeah, I'm confused really here. So, because I would have said that this is a DC motor and this is brushless. And based upon the way they're talking, that sounds about right. But then this has a label on it that says brushless DC motor. That's why I was confused earlier. If I show you. Yeah, anyway, so looking at the curriculum, it does say here, DC motor, brushless DC motor. Yeah, exactly. So all pretty straightforward, really. I just had to connect. So here we've got the motor driver, which if you watch my stepper motor videos, these like steppers and servo motors, which is what I would call this. Looking at this, if I saw this in industry, if I saw this in the factory, I would call this a stepper or a servo. So they're just calling it a brushless DC motor. So whatever, I need to learn the lingo, I guess. All right, so that's wired up now. So essentially this thing here is now able to power and control this thing here. And we do have some. So I don't have any power here. Do I need it? Yes, I do. Okay, how do I give it to it? Ah, okay. I'm not powering. Am I powering this? No. Okay, so I'm not supposed to be looking at the schematic. I'm supposed to be putting these into here. Oh, this is cool. So now we'll be driving our. I'm gonna call this a stepper or a servo. But yeah, well, let's call it our brushless. I think this is the brushless DC motor. This is a normal DC motor. So the brushless DC motor we should now be driving, and I should be able to turn this on. Yep, and then run it. Am I right? Will it run? No. So, alright. That didn't run, but that's okay. Is that because... Okay. Oh, yeah. Look here. My switch is open. So, let's close this switch. Now, should we turn this on? We don't have an LED to say that it's on. And I say this at work as a joke to everybody, but I mean it. Like, we should have LEDs everywhere. So, if I was to upgrade this thing, there should be an LED here to say that it's on. Oh, it's currently off anyways. That's on now. Alright, I can't even tell. Like, okay, there's a switch. Yeah, so off, on, but sadly no LED here or here. But okay, that might have to do with like making it sturdy and safe. It's very sturdy. Alright, so that should be on now. Do I run it? Will it run? No. Again, I'm not reading the instructions yet, so I should probably do that before I start trying to mess about. So, let's read the instructions. Where are we at? So, build the circuit shown above, which I think I've done. I've got 12 volts coming in. I've got a switch here in my negative there. Yep. And that's going to the driver. Yep. And then that's going to there. Cool. All right. So, set the speed pot on the motor generator pair to the minimum output position. So I assume that's fully left. Close the switch on the electronics board. Brushless motors need to be started at a slow speed and then ramped up to full speed. Turn the pot slowly. I think I might have put it on full whack. Turn the pot slowly to make the brushless motor start rotating and speed up. Use an oscilloscope. So, okay, this is meant to be running then. Oh, we're getting some jittering. Oh, no. Nope, something's not happy. What is it? Interesting. So, I don't have anything at the back here on this control. Ugh, this thing's heavy to show you guys. On this bit here, I got nothing connected, which seems like a problem. I also have here direction. Oh, this switch is just direction. It's not power. Okay. Interesting. You'd assume that on off would mean power, no? Is that not, would that not be power? Okay, so that's just direction. So maybe I'm spinning it a way that it's unhappy with. So let's try again. Nothing like that. Okay. So when I do that, I get nothing. If I switch it on, what I think is on now. Okay. Now it's going. Ah, that is beauty. Oh my gosh, that sound. I've missed it. I've missed it so much. I've been at a desk for the last 5 months. That is so nice. You hear that the ramp up. Oh, honestly, it's a great feeling. You know, you programmers out there that all you do is program, I feel bad for you guys, because hearing this thing spin up, like if you write some code and you make that and you just make that go, and you just like, oh, he ain't going, look, what, he's stuck now. Why does he get stuck? Let's go. Maybe maybe I'm doing it too fast. Slow ramp. So it didn't get stuck there, but it was about to get stuck. Let's go again slowly. Okay, and then that's a bit dodge. But okay. Ah, this is cool. All right, cool. So, what did he ask us to do? They wanted us to use an oscilloscope to look at the waveform generated between sockets U and V on the brushless motor driver rotated at max speed. Okay. Full send to max speed. I love it, man. I absolutely love it. It's like, I don't know what time it is. I think it's like midnight on a Sunday night. So I might be peeing some people off with the vibrations. There's a fair bit of vibration when that goes at max speed. Yeah, nothing I can do to stop the vibration. I'm not gonna do it at max speed just because it's midnight on a Sunday. So, using an oscilloscope to look at the waveform generated between sockets U and V. So how do I do that? So between sockets U and V, suitable settings are shown below. Sketch the waveform on the graph. Okay, so there's our signal. So what do we have here? Let's crank it up to max speed to see what we get. Okay, in auto. Okay, I'm using the cheapo scope here, so I might pull out a better scope. Okay, so that's how I do my time range. So it says 2 millisecond time range. So 10 millisecond, 5 millisecond, 2 millisecond. Oh, we're getting a little janky sine wave there. 2 millisecond per division. Voltage range plus minus 5 volts. How do I change that? Oh, there's 5 volts. Okay, so I'm on 2 milliseconds, 5 volts there. Trigger mode says auto, but okay. Alright, and then trigger direction horizon. So let's go full speed. Let me use a better scope and then see what we get, because it's all a bit janky. Alright, 1 second. Alright, so we've whacked out the big boy. Now, like that kind of makes more sense to me. So we've got some form of like janky-ish sine wave, modulated sine wave. So on full speed. Okay, so it's a bit of a, is that full speed? Yeah, I guess so. Yeah, I mean, you could say that was a sine wave, I guess. All right, what's next? So sketch the waveform. So what? Three phase. Let's so yeah, that's the sort of signal that we're getting. So what? The three-phase power supply is housed in a DC brushless motor driver box in a HP2001. So that's this motor driver. It generates a complex three-phase waveform that includes gaps where the controller takes voltage measurements to determine the position of the rotor and control the timing of the waveform. I wonder, is this a custom-made matrix driver, or is it a bought-out one? Because that'd be, if they made their own, that'd be incredible. I should say, if we made our own, that'd be incredible. I'd like to open this up and see what's inside, actually. So, where the controller takes voltage measurements to determine the position of the rotor and control the timing of the waveform. For this system uses a technique called back EMF sensing. For this module, a voltage varying between 0 and 5 volts controls the speed. Okay, on the page below, you can see the photographs of the brushless DC motor dissected with the main parts labeled. Okay, you can see the Hall effect sensors used to sense rotor position. Okay, in the student handbook, explain the key differences between this motor and the DC motor. Cool. And then we do some AC generation. All right, what happens if I switch direction? I'm a bit scared now. So I've got a switch here as well. That obviously it says direction, but I kind of think that's just power. But let's turn it down and then switch direction. Is it going to slam one way and go the other way? Okay. Oh, interesting. So it doesn't, okay, so that maybe it is direction, but I can't see it going a different direction. That seems to be going the same direction to me. No, I've kind of broken it. I'm giving it max juice and it's not going. Okay, so that's going now. And then if I fling it the other way. Nice. That definitely turned around there, I think. Doesn't sound happy about it. So that's that way. Oh, he's not happy. So yeah, what I'd like to know now is what's happening there. What is that? If you could tell me, please leave a comment below. Out of all the things, so you know, I've got a bunch of things that I'm interested in, and as always, you kind of like, you get like, you know, I'd like to know what's going on inside here. I'd like to have a look at the microcontroller programs in here. That would be interesting for me. I'd like to learn about FETs again and figure out what's going on there. I'm kind of interested in how this resistance is changing the input, or how, you know, what the program's doing. It's looking at the input on one of the microcontroller pins. I'd like to look at that circuitry there. I'd like to know what's inside here and open up this box and figure it out. But I guess out of everything I'd like to learn, probably the one thing is what's happening there. So that, yeah, anyways, all right, next video, hopefully I'll keep doing these. If you enjoy it, leave a like, and yeah, I will start this AC generator worksheet, I think, next. Take care, guys. Bye bye.